plus or minus 1 and plus or minus 3. Okay, now guys, this is not the answer to the potential list. You have to actually use this to write your list. Okay, so I take each of these tops and I divide it by the bottom, and I have plus or minus 1 over 1 is 1, 2 over 1 is 2, 4, I list all of those out. Because when we agree, wouldn't we agree when you divide all of those tops by 1, you're going to get the same number. Okay. Then I need to divide them all by 3. So I have 1/3, 2/3, 4/3, 5/3, 10/3, 20/3. You do not have to check these all. We're going to cheat and now look at our graph. It just helps us figure out which ones are. That's my list. Questions so far? Would you put the polynomial in your y equals, please? Okay. What was the degree of my polynomial? 4. How many of those 4 zeros, because now I know there's 4 zeros, how many are real? 2, because there's 2 at the graph. That means I have 2 imaginaries. Those 2 reals and 2 imaginaries are your factors, 1, 2, 3, 4. Okay, so that's how we're going to factor. So first, it's pretty clear negative 4 is a 0. Do you need me to test it, or do you trust me? Okay. The other one looks like it's between 0 and 1. So our options could be 1/3 or 2/3. And I would check those. I would go to the table, and I'm going to just confirm that 1/3 is indeed a 0. Okay. So then I'm going to write down, I used my graphing calculator, and the zeros that are real are negative 4 and 1/3. Okay, so simply put, what we're going to do, and by the way, I'm doing degree 4, so I have to do division twice. If it was degree 3, then it would probably be 1 real, and then you'd only have to do it once. I won't give you anything more than degree 4. Okay. Does it matter which one you start with? No. Pick one. It's your lucky day. Which one you want to do first? Negative 4? Okay, so I am going to take, it's going to be exactly, the 0 matches what's in the box. When I write it as a factor, it's going to be x plus 4, but I have a 3, I have a negative 1, a negative 33, a 71, and a negative 20. Okay, so this is a 3. What goes here? Negative 12. Good. Then I do negative 1 plus negative 12 is negative 13. Negative 13 times negative 4 is what? Don't check your math. Positive 52, right? Negative 33 plus 52. Positive 19. 19 times negative 4. Negative 76, right?
What's 71 plus a negative 76? Negative 5. Negative 4 times negative 5 is 20. This just confirms I got it right, because what's my remainder? 0. Now, at first you might say 1/3 is right. It's just, come on. It's gonna be nice because I know the remainder is gonna be 0. So it's not gonna be. It's gonna end up being nice. Let's not make a mistake. Do not go back to the original. This, I just divided this off, and this is my result. That is what I'm dividing the 1/3 off. Otherwise, I'm gonna go all the way back to the beginning. So I'm gonna rewrite my new polynomial without the remainder. And now I'm going to divide off the 1/3. All right. Cool. Easy so far. What's 3 times 1/3? 1. Negative 13 plus 1 is negative 12. Negative 12 times 1/3 is, and it's going to be a negative 4. Good so far. 19 plus negative 4 is 15. Phew. 15 times 1/3 is 5. So then I am going to write this as my irreducible quadratic. So the question for C is we're going to write it as a product of linear and irreducible quadratic, and then the last thing we're going to do is go all the way to linears. So whatever you divided off, you write as your factors x plus 4. I know this would be x minus 1/3, but what was the way I taught you to write it? 3x minus 1. And what the irreducible quadratic is the results after you do your division. So it would be 3x squared minus 12x plus 15. Linear, linear, irreducible quadratic. I'm wondering if I had you do this on another page. Did I give you 3 pages of notes or just 2 yesterday? Just 2, right? This is the second one. All right. Are you done writing that down? Okay, the last thing that we're going to do, and you're going to just flip this over on the back, is go one step further. And the one step further is to go all the way down to the linear factorization. That's what this is called. So I'm going to go ahead and write down my stuff so I don't have to keep flipping back and forth. Okay. So for your linear factorization, they all have to be linear factors, meaning they all have to have an x and an x. So I have 2 of my 4, so now I need to get this into an x and an x. And so what we're going to do is we're going to solve this. On the best day, it's going to be just an x squared, and then you can solve it by just using square roots. But this, unfortunately, can't be solved that way, so we're going to run it through quadratic formula. Okay, the very first thing, I like smaller numbers. The very first thing I notice, and hopefully you notice it too, aren't those all divisible by 3? So I'm going to, if you don't notice, is it a big deal? No, it's not a big deal. But I'm going to pull that 3 out to the front, which is then going to pull it all the way out to the front. Okay, so now I have 3x plus 4. I'm pulling this 3 out, and I'm putting it over there. All right, that would leave me with, let's see, 3x squared divided by 3 is x squared. 12x divided by 3 is minus 4x, and 15 divided by 3 is plus 5. So to get my last 2 zeros, let's do quadratic formula. Okay. So we have x equals negative b. What am I going to write? Opposite of negative 4 would be positive 4, plus or minus square root b squared minus 4ac all over 2a. So, in my quadratic, negative 4 squared is 16, and I have 16 minus 20 over 2. You don't have to write the other step if you already knew. What is 16 minus 20? Yeah. So we have the square root of negative 4 all over 2. And what's the square root of negative 4? 2i. All right. So sometimes it's going to be like this, I don't know. What if I got the square root of negative 10 and it's not nice? Then you're going to write that root 10i. Right? If it's an exact one, you can take it out completely, but if not, you're just gonna, what's the square root of negative 17? Root 17i. Okay. So some of them won't look nice. If I divided this by 2, I hope you see that I get 2 plus or minus 1i. You've seen that? Because I could divide both of these by 2. Okay. All right. How many numbers is that? 2. Now you can see why they always come in pairs. And then the last step is I'm going to write those as factors. So carrying down what I had before, I had this 3 out in front. I have these 2. And then now I'm going to write my last 2 zeros as factors. So we have 3. We had an x plus 4. We had a 3x minus 1. We had a x minus 2 plus I, and an x minus 2 minus I. Bam. And that would be all linears.